Welcome back to week 4 discussion on a potpourri of things. In the previous video, I walked you through how to write a cis and trans isomers, actually identify a cis and trans isomer, and identify when you should use a Z and E isomer over a cis and a trans. Okay, I've given enough examples. That should be plenty to get started on that topic. Now, if you notice, towards the end of the video, I started to include elements that we have not touched upon, at least in the last 3 weeks. We focus purely on compounds containing just carbon and hydrogens, right? Because that's foundational. Now, I'm going to give you a laundry list of some common names. You don't have to memorize them, at least not at this point. But eventually you may have to start, start figuring this out. Okay. All right. So with that said, okay, the first element, the list is, okay, if you see this group, I always put a bond because this is through the bond it attaches to the carbon and hydrogen chain. If you see this group, it's called, I'm going to write the list and the name for it. You say amino. Okay, this is called amino. Amino means amine. This is amine. Okay, and then when it's in a compound, it's called amino. Okay, and then Cl, Br, fluorine, and iodine. Okay, these are all, when they're by themselves, have a different name, but when they're in a compound, you just add a O. Chloro, bromo, iodo, sorry, this is fluoro and iodo. Okay, if you're a little bit off with the spelling, it's okay, you will eventually catch up and get it right. And then there's one more I do want to write here. It's OH. Okay, this is the anomaly in the list of things I've written. It's called hydroxy. Again, by the end of the semester you would know it. You may not just get it right away. All right, but these are names. I will not give this list on the test. This is something you do have to memorize or find a way to remember it if you don't want to memorize. Okay, there's ways you can do it. Okay, so going back to our compound. All right, so let's say I'm going to actually start with the cis and trans first before I go on to a Z and E, because things get a little complicated. So let's say I give you this, okay? Say this is the compound. First, you have to name before you even worry about cis and trans, because figuring out cis and trans is very, very, very easy. Okay? Now, chlorine is a bigger group, right? Now, if you're still stuck, how am I supposed to know which one's bigger of the two? Okay, you can get the periodic table. Okay, in the periodic table, carbon's atomic number is 12 and hydrogen's atomic number is 1, but there's 3 of them, so this is 15. This is 35. This is the atomic number. This is 35. This is 15. Okay, so 35 is bigger than 15, right? Now the question is it should we use a cis and trans or Z and E? If you look on either side of the double bond, the groups are exactly the same. So we use cis and trans, right? Only if at least 3 groups are different, we use Z and E. Now, among these two, this is a bigger group, so it gets A. This is smaller of the two, it gets B. Among these two, this is the bigger of the two, and this is smaller of the two, right? Clearly, A and A are of opposite, right? So this is a trans. Right, now comes the naming part. Now, as I've always said, you want to first write it as a straight chain. Okay, looking at it this way, if you have a trained mind, you would look at it easy. But for people that are getting started, what I recommend is write it this way. Okay, write it straight, just like your brain would see it. Okay, this is what most of you are comfortable with. Okay, now does it matter which side we start numbering? No, the double bond is even and everything looks the same on both sides, so I'm just going to start numbering from right to left. So Now comes we still have to fill the spot with the actual name, right? We got two substituents. This is 4 carbons, so it's butane, and the double bond is between 2 and 3, so it's 2 butene, right? And then you got two substituents, chlorines, on the second and third carbons, right? What does Cl, when in a compound, it's called chloro, right? So it's 2 3, same thing, there's 2 of them, dichloro 2-butene. So you come back and write here trans 2,3 dichloro 2-butene. Okay, now let me give you a different compound. You gotta still keep that list in mind, but let me give you a compound. So this time you have to tell me whether it's a cis and trans or Z and E, and then you go figure out the Z and E or cis and trans, and then you also name the compound, put them all together. Alright, so alright, I've added a little bit of complexity to this problem. So first figure out the easy thing. Should we be using a cis and trans or Z and E to name this compound? Well, look on either side of the double bonds. Are all the groups the same? I mean, this group on this side, this is the left of the double bond, this is right. Do they look same? No, they look completely different. So we use a Z and the E format, right? Now a question of should it be Z or E, right? We always look at the element that's directly attached before we look at the size. This is the reason why I'm doing this. Your brain would probably tell you, hey, it's got to be this is bigger. If I add all this up, it will be bigger than Br. Well, you can try that, but I'm telling you that you focus on the element that's directly attached to the carbon first before you branch out. And if I bring back that priority list, okay, carbons, we're only focusing on the element that's directly attached first. Okay, carbon, bromine, chlorine. These are the only ones that are directly attached to this carbon right here, right? So between these two, bromine has a higher priority, so A. Despite the fact this might look like it's bigger, well, where is it first attached? This is where it's first attached to this carbon, and that means this is B. Same here. This may look like it's bigger to your eye, but it's not always just the size. Only when you have everything the same, then you worry about the size. But in this case, chlorine is higher than carbon. You focus just on where it's directly. These are the two things that are attached, and so this would be A, this would be B. Okay, A and A are on the opposite side, B and B are on the opposite side, so this is an E. We got the first part of it done, right? Now comes the second part. I'm gonna actually delete this so I get all the space I want to do what I want to do. Okay. So that means we know it's E. Now it's just a matter of figuring out the name of this compound, right? What did I say? First, go ahead and write it as a straight chain. That's the only way you're gonna help yourself to make this easy on yourself, okay? All I'm doing is, even if you have to leave it this way, that's fine. Just write it wherever you want, but make sure you write it in this format. Okay, now I threw the CA3 in here purposefully to see if you still remember the naming rules from weeks 1, 2, 3. You cannot just forget it because we're in week 4. Okay, now which sides do we start numbering from? Okay, this side looks a little bit more crowded, this side looks a little less crowded, right? Clearly this side is more crowded, right? Right, so we start from the side 1, 2, 3, 4, 5, 6, and 7, right? Right. So that means now you still, the Z and E is only for the position of the isomers, okay? It has nothing to do with the name. The name is still governed by what you learned in the first 3 weeks, except this time I've given you the names of it. Cl in a compound is chloro, Br in a compound is bromo, and we already know this. You can't tell me you don't know what that means. All right, so that means we have 2-methyl, this is bromo and this is chloro. Br is the first in the list, so it's E, 4-bromo, 5-chloro, because B, C, and then M, 2-methyl, right? The double bonds between 4 and 5, and there is 1, 2, 3, 4, 5, 6, 7 is the longest chain, so it'll be 7 carbons total, and that's heptane, right? But it's a double bond, so it's 2-methyl 7-heptene. Does that make sense? This is really long. Okay. Okay, so you would have to memorize this at some point or find a way to remember it. Again, there is not going to be a zillion of these for you to remember. Whatever I wrote on there at least is basic, some things you have to remember, but you just still cannot forget how we learned naming. Okay, you can't just forget the naming part that we spent 3 weeks trying to master it. Okay, so let me give you one more compound. You can pause the video and then continue watching when you worked it out, and then see if you got it right. Very good. So let's continue with the problem. Okay. All right, so you gotta give me the complete name, okay, which should include whether it's cis and trans or Z and E, and then probably the full name of this compound. All right, go ahead and pause the video at this moment and practice it to see if you do get it right. All right, when you have it, continue watching the video to see if you did get it right. All right. If you had paused the video and worked it out, you probably figured out right away that we are going to be using a Z and E because the 2 groups on either side are not identical. Even if one is different, that means you have 3 different groups around the double bond. So that means we are using a Z and E, right? All right, now go get it. Now this carbon is attached to this carbon, but this is extending further, so this is bigger of the 2, so it's AB. Here, this may look like it's big, but the carbon, it's only attached to the carbon first, but here it's attached to chlorine. And if you remember the priority list, let me bring it back. Chlorine is bigger than carbon on the list, so that means this gets A, this gets B. A and A are on the opposite side, so it is a E. Now the question of naming it, right? So let's go turn this compound into a straight chain. Okay, so what would it be then? CH3, CH2, C, CH3. I'm just writing it as straight instead of it being crooked like that, right? This would really help you on a long run. If you do it this way, you're not going to get it wrong. This is also a good place for you to review your naming knowledge. So it'll be, this definitely looks more crowded, so 1, 2, 3, 4, 5, 6, 7. So it's 7 carbon, it's heptane, but there's a double bond, so it's heptene. Okay, and the double bond is between 4 and 5, so it's 4-heptene. That's the last name of this compound. We still have to go get the rest. This is a chloro, and this right here is, we know, is a methyl. Okay, but chloro comes before methyl and it's on 4, so E4-chloro 5-methyl, sorry about the space, it's 4-heptene. I can actually delete this over here, bring it back here, 4-heptene. That's how you label the compound. Okay, very good. So let me give you one more practice problem before I want to move to the next concept. So how are we doing with time? Okay, I got a little bit more time on this particular video, so let me delete this. Let me give you one more compound here. Okay, such a massive compound, take one step at a time. There is no rush to get this done. So pause the video and I'll probably give you an answer to this in class, and probably create a separate video to address this particular problem. You're welcome to pause the video and work it out and have the solution ready for classroom discussion. Or if you're still finding it difficult, whatever I have covered, before this compound, you may want to ask questions on those first before you proceed to work out something like this. Okay, you see, we're in week 4, so there's got to be some level of complexity to the learning. We've got to move away from just carbon and hydrogen compounds. So go ahead and give this a shot, and when I see you all in class, I will work this problem out if none of you get it right, and then I will create a separate video for my YouTube viewers to get this compound named right. Very good. In the next video I'm going to start something new, but just along the lines of CnH2n. Alright, stay tuned.